Hi, I'm Himanshi and I'm making this video to explain you about the Azure Databricks end-to-end project which I have created for my learning. So these are the project details. The project is of domain data engineering, Azure Databricks end-to-end ETL and visualization project. This is the description about the project. This is developed. I have developed an end-to-end data pipeline flow in Databricks that is helpful for extract, transform, and load. I have implemented medallion architecture. Medallion architecture means it contains three layers of the data, which is bronze layer, silver layer, and gold layer. A bronze layer has the raw data, silver layer has the transformed data, and the gold layer is the main serving layer for which all your data models will be handled here. I have used Spark streaming for real-time data processing using autoloader and built dimensional data models like star schema. So these are the data models which I have created at the gold layer, which is the most enriched layer. And the star schema means basically the data warehousing concept in which we organize our data in such a format that it contains fact tables and dimension tables. Fact table contains the numeric values and dimension table has all the dimensional data. So this is implemented at the gold layer, and I have used declarative pipelines for the gold layer data modeling. I've handled the slowly changing dimension of the data, SCD type 1 and type 2. So for SCD type 1, it is basically absurd. If we have a data, say first we loaded our historical data, and then after that we got incremental data, and incremental data had some updates over the historical data, as well as there could be some new data which might be entering. So for SCD type 1 we do absurd, means update the old data if it is coming as incrementally new, incremental data if it is coming and it is an update over the old data, so it will update it. And then for new data, if it is coming as an incremental data, then it will simply insert the new data in the final table. So that is SCD type 1, which is absurd. For SCD type 2, we do not directly update the data which is already there if it is coming as updated data in our incremental load. So what we do is we prepare history, we maintain a history for all the records. So say if we got a data in our historical load, and then in the incremental load there was an update to the already existing data, then it will maintain a history where it will maintain it like start date, end date with the versions. So that is SCD type 2, and all the new data will always be inserted. So those slowly changing dimensions, I have handled it in my project, and data is being processed via Spark. This is nothing but a data processing framework which I have used, and I have orchestrated the whole flow using Databricks workflows, and there is a single automated pipeline for both historical as well as incremental load. So I have implemented parameterized approach in my pipeline such that we can use the same pipeline for historical and incremental load. And once all the data processing is done, I have connected Power BI reports via gold layer, and then using that enriched data I am visualizing it in Power BI. So this is the architecture of my project. The main focus of the project is Databricks services. So and I have used the cloud, which is Azure cloud, in my project. For Databricks, so I have connected my Databricks account with the Azure cloud to store all the data, external files for say bronze layer, silver layer, gold layer. So all the external files will be stored over here, and then the source also I am storing here. So the source files I will fetch from here using the Azure Databricks services, and then I will store in the bronze layer. So in the bronze layer we have nothing but the raw data which we have fetched, and then that bronze layer raw data I will be processing it using PySpark and then storing it in silver layer. After processing I will be storing everything in silver layer, and once silver layer we have our processed data, then I shall be implementing the data models, which is star schema, in which I will break down my data into fact tables, dimension tables, and also implement slowly changing dimensions such as type 1 and type 2. Once we have all our enriched data in the gold layer, then I shall be connecting it with the Power BI and visualizing it. So let me show you the pipeline which I have created. So this is an end-to-end pipeline which is automated for both historical and incremental load, which I have created. So how am I maintaining the historical and incremental load is using the job init load flag. This is nothing but a flag which tells me whether it is an initial load or a incremental load. So for initial load it is going to be 1, and for incremental load it is going to be 0. And my notebooks are also parameterized in such a way to handle those scenarios. So when it is the very first load, so when it is a very first load, which is a historical load, so my code is implemented in such a way that if we do not have any tables, even if the table is even not there, then also it will handle everything. So for the very first load I am checking if my load type is initial flag or incremental flag. So for the very first thing, the activity, the task which is going to run is this if condition. If condition will check whether the parameter which I have passed has a 0 in it or 1 or in it. This is to give you the flow for incremental and historical load. So if it is an initial load, at that time I am dropping all the tables which are there, so that everything will be created as fresh. So first it will check if it is an initial load or a incremental load. If it is an initial load, then I am running a pipeline. If true, then I am running a pipeline which will drop all my tables. So this is the notebook in which I have implemented all my code for the cleanup. So first is the gold layer cleanup. All the gold layer tables will be dropped off, and then I have also removed all the files which are there in my ADLS location. So this is the ADLS location. This is the location which is connected with my Azure Databricks, and here we store our source data. So this is nothing but our source data, where I have regions, where I have products, where I have orders, customers, all these are there. So for the first time load I can only pass the first Parquet file, and then for the second time incremental load I can give second also. So this is the way I have implemented it. So for the first time load, which is historical load, it will drop all the files which are there, not the source file. Source file will always remain as is, just the different medallion architecture layers, which is silver layer, gold layer, bronze layer. I have dropped all of these, and this metastore is nothing but the Unity catalog metastore, which is stored at this location, which is connected to it. So once all the tables are deleted, so first is all the gold layer cleanup, all the table drops, and then the file cleanup for ADLS. Then for silver also similar thing, for all the silver table cleanup. Then removing all the ADLS files for the silver layer. So here if you see, I have given the exact name. I could have skipped it. So if I skip it, it will remove everything inside this location. Whatever are the folders, files, all will be removed recursively. Over here I have used a shortcut to directly give this much path, so inside it everything will be deleted. And this is the bronze layer cleanup, in which I am deleting everything inside the bronze layer. So this is the cleanup activity which is done for the historical part. Then there is the notebook which is being run, which is parameter. In this parameter notebook, I have a data set which is defined as an array, which is in this array we have key value pairs, which is file name, orders, customers, products. So this is a metadata type of notebook which will be used to load all these tables, all these source data into our bronze layer. So I am passing this variable also in my task value jobs. So basically once our job will run, this parameter will be passed in my job, and I can use it further on all these parameters dynamically. So this is initialized over here. So I am looping over an activity. So if you see over here, output data sets. So I am taking this value output data set, which will come from here itself, output data set, and I am passing it inside this loop activity. And inside this loop activity, a branch autoloader iteration, what I am doing is I am passing the file name, which is nothing but input dot file name. So for every iteration, what will happen is this whole data set so this whole data set will be passed as a parameter dynamically for this loop iterator. So for this loop iterator, it is tasks.parameter.value output data set. So output data set is nothing but the whole data set. So this is the input. So for this input we have multiple items, and these items will be picked one by one in our loop. So first it will, if you see inside, so the whole thing is being passed, and then inside it we have input dot file name. So every item will be passed one by one in this loop, and then dot file name, which is nothing but the value of it is orders. So orders will be passed for this particular activity. So if I go to branch autoloader iteration activity, so it is this file which will be executed. So if you see, I have parameterized everything. So first it will pick the file. This is just defining the parameters. So in our pipeline, it will be passed as whatever are the values for the parameters. So say orders, customers, products, everything will be passed dynamically. Then I am so the data is first at this place, source. Inside customers we have this as data, our source data. Then we have products, this is our product data. All the data is inside the source container. So what we are doing is, from the source we are putting into our medallion architecture bronze layer. So in bronze layer we are putting all those data, which is nothing but our raw data. So this is that step where we are fetching everything. This is just to select what is the data over here. So what we are doing is, to fetch only the incremental data, I have implemented the autoloader, and autoloader via Spark streaming. So it will fetch only the incremental data, and that particular file will be pushed to bronze layer. So this is the data writing. So only the incremental data will be fetched. If I upload if I rerun the same pipeline again, then it will not fetch the same data again. It will not do a full load. It is just an incremental load via auto loader using Spark streaming. So this is implemented over here, and now our data will come from the source layer to branch layer, one by one, for all the files, for orders, for customers, for products. So now all our data is inside our branch layer. Once it is inside our branch layer, then we have implemented the data processing notebooks, which is silver, customers, orders, products, regions. So all these notebooks helps us to process our branch layer data. So this is silver customers. So this will help us to process the customers data, in which I am reading from the same place, which is branch customers. So in the previous task, all our data is loaded till branch layer. So I'm reading for customers, and then I am doing my transformation, such as remove rescue data. So we in this table we have rescue data column. So this I am renaming or deleting whatever task and transformation I want to do. So this is, and then I have creating new column, which is as domains, and I have specified how, using the email @ separator. After that, whatever is the value, I am fetching it as domain. So these are all the transformations. I am making analysis also over there using the domains, aggregating, calculating total. So these are all the transformations and processing analysis which we can do at the silver layer. So for example, I am checking how filtering all the domains which has Gmail. So all those processing is being done at the silver layer. And then for the full name, I am creating a new column, which is concatenation of first name and last name, and dropping the first name and last name as we already have now in the full name column. So all these processing is being done here. Once the processing is done, I am putting this data in the silver layer. So till this step, we got all our data in the branch layer. After processing for this particular task, we have our data for customers in our silver layer. So all those data I am putting in my ADLS location, and after ADLS location, I am also creating a table out of it. So this is a drop and create table, because for every run it should be a fresh. So for that part, I've created it, and then I am doing a check on that data also. So this is the processing which is done for silver customers. Then we have silver orders. So for silver orders, again I am creating a data frame from the location branch orders, as we have everything at our as we have our raw data in the orders container. Then I am displaying it. The same way I am doing all the transformations which I want to do. If I want to rename the rescued data column, if I want to drop it, if I want to do any other analysis, if I want to change the data type of any other column. This is the year column where I am creating a new column using the order date and year function. Then I have created a flag. Flag is basically a ranking which I have defined for dense rank, and then it is partition by year and order by total amount. And this is a new column which I am creating for dense ranking. So this is the column. Then similar way I can do for rows also. So dense ranking, rank and row number, these three functions I have implemented. In the same way we can also do using the classes. So using the class I have created a class window, and there I have defined my dense rank function and row number function. So we can do this way as well. And here I am creating an object of that class, and then using that object I am passing my data frame and the function, giving the function name which I want to perform on this particular data frame. So this can be done this way as well, which I have implemented. Then after all the processing, I am writing my data to the silver layer inside the orders folder. So this is for silver orders. Once I have put my data in this particular location, I am also creating a table on top of that path, which is again drop and create, so that every time it is a fresh load. Then we have silver products. So once our data is completed, we have for customers as well as orders, then silver products. So all these tasks are nothing but parallel processing. So this is for products. Again I am checking my data from bronze layer products folder, and I am dropping whatever the columns I do not need. Over here I have tried to implement functions. Using functions I am doing any modifications which I have to do. So I have created a view from the products from df. Using the df I am creating a temporary view, and the name is products. So this is the function which I have created, which is a SQL function, in which I shall be passing my price and calculating price 19. So this is discount which I am calculating. And then so this is the function definition which I have implemented, and the use of it is over here. So we can directly define the function name and pass the column name on a particular table. So this is the transformation which I have done using the SQL functions. So if I need to implement, so if I need to use the same thing with the data frames, then we can use expr and pass it in this syntax. I have also tried creating the function which is for language Python, and there is this is for doing putting all the p_brand columns as upper. So it will convert the lowercase or uppercase, it will keep everything as uppercase. So you can see over here it is modified. Then I am writing the transformed data on my silver products location in ADLS. And once my data is written, I am also creating a drop and create table to for the silver layer, which will be always full refreshed. Then we have silver regions also. For regions it is a static table. So how I ingested this table in the bronze layer is, as it is a static table, we have data ingestions. So inside data ingestion we have create table from ADLS. So over here we can select our these are nothing but the external locations which I have created. For this ADLS location, all the containers are connected to Databricks via external location. So these are the external locations. So if I select source and then products, then this particular table, then we can preview the table, and then once it is previewed, we have data, then we can directly create it. So this way I have created as it is a static table, and this can also be created using the same way which I have implemented for customers and products. So for silver region, there is not much transformations which I have done. So I am fetching the data directly from the table once the table is loaded. I am fetching the data from there, and I am dropping all the unnecessary records, unnecessary columns, and then I am pushing my data to the silver layer regions. In silver layer regions folder I am pushing my data. So this is one of the way which we can load our data. If it is static, then we can directly data ingestion, we can use it. So then I am also creating a drop and create table on the same path, which will be a full refresh every time. So till here all our data which is in bronze layer is processed and sent to silver layer. So after that, these are the gold layer data. So inside gold layer I have implemented star schema, which is a data warehouse concept in which we organize our data in the form of fact tables and dimension tables. So my fact tables is fact orders, and my dimension tables are customers and products. And as I already told, regions is nothing but a static file which is being used in this data flow. So gold layer, in gold customers I have implemented the SCD type 1, which is using the PySpark, and for gold products I have implemented the SCD type 2, which is using the declarative pipeline. So first checking the gold customers. So once we have all our data in the gold layer, in the silver layer, so in silver layer we have in our silver location as well inside this folder, and as well as I have created the tables on top of it, so we can also directly fetch from there. Then I am removing any duplicates if any. This is the initial load flag. Now this particular parameter I am passing from the pipeline itself. So from pipeline, from here if you see 0, so 0 will be sent for this particular notebook run. So how is it implemented is, if you see inside the task, jobs.parameters.job init load flag. So this is being passed to the initial load flag for this particular notebook. So if you see initial load flag, so this will have value 0, whatever is being passed in the pipeline. So when it is 0, it is incremental load, and if it is 1, initial load flag, then it means initial load. So considering it as an initial load, it will fetch all the customer silver table data. It will make all the changes, drop the duplicates. This is nothing but the parameter which I have created. Then this is the part where it will work differently for incremental and historical load. So how it works is, for historical load, load flag will be 1, and all the tables in the very starting for the historical load are already dropped for this particular activity. So if you see this parameter, notebook will run if this particular. So how it is connected is, see, this is if. So if it is true, then it will go to this particular notebook, and then it is connected with this particular notebook. And also the false part is also connected with this particular notebook. So this notebook has dependency on this being succeeded properly or directly with the false. So if at least one is successful, any of one of the dependency is successful, then it will directly execute this part. So for gold customers, what will it do is, for the initial load it will come over here as the initial flag. Load flag will be having value as 1. So for 1 we just want the schema, because the table, if you see Databricks Kata Gold dim customers, this is already dropped in the very starting of our table. So we cannot give the name as our gold table name, so we can give any other table name, because this is just to get a schema for that particular table, as it will already be empty. So what I have selected, any table name which is existing. So before this particular load, our silver tables will be created. So use any silver table and just give 0 for all the metadata which you want in your gold customers table, and where 1 is 0, so that it does not have any value inside these columns. And also for now, if it is an incremental load, so for incremental load what I have done is, we want all the data which is already existing in this customers table as well to implement the SCD type 1. So for SCD type 1 we will match our old data which is already existing in our dimension table with the new data which is coming incrementally, and then we will match if on the basis of dim if on the basis of an ID it already exists in our table or not. If it exists, then we are directly going to update it. If it does not exist, then we have to insert that newly record. So for that part, for the incremental load, we are checking whether that whatever is the old data we are putting in df old, because we would require it later. So for df old, I am renaming all the columns with old prefix. Then this old data, df old, which this is for the df old will have the old data if it is an incremental load, and if it is an historical load, then our df old will be empty. So we are joining with the df. Df is nothing but the new data which we got right now. So we are joining the old with the new data which we are getting right now, and we are joining on the basis of customer ID. So joining on the basis of customer ID, and it is a left join, such that we left join because we want all the data which is coming as newly and join with the old data. So if this particular customer ID is already there in the old one, it will be having the customer ID value. The old customer ID will have some value. But if the DF contains a new record in which the customer ID will be new, means it does not exist in the old data, it is a fresh new record. So the old customer ID will not be able to match with any of the old customer ID will not match with the customer ID, hence that will be having null. So in this way we can fetch which particular records we need to update and which particular records we need to insert. So df new, this is the new data frame. So if we join, df join is our joined data frame. So this is our joined data frame, and when we join, we are going to filter it. If the old customer ID is null, means it could not match with any of the old customer IDs, means it is a new data. And similar way I am creating df old if the old customer ID is not null, means the new record, means the incremental record had a join with the old data which was already there. So it means we need to update those records. This is the separation for old and new records. So over here I have implemented the process for old. This is the process for updating the records. So for SCD type 1, if the record already exists, we need to update. So what columns do we have? We have is customer ID, created date, updated date, and customer key. So dim customer key is the surrogate key which is being used in the data warehousing concept. It is such a way that this will help us to uniquely identify our records. So if a record already exists, if a customer ID is already being matched, joined with the DF, if the customer ID between DF and old DF is already matching, so we do not need to have two columns. We can drop this old columns directly, and then what I'm doing is I'm renaming the old customer key with the customer key, because the customer key will remain the same as the data is not new, it is an old data already, so it will remain the same. So I am just renaming it, and the created date I am updating to the for the created date we need to use the old created date only, whatever was there initially. So this whole transformations which I am doing is only for the old data, DF old. So if old data is there, means our incremental data is being joined with the old data, means we need to update those records, not insert, because it is already there. So we will drop these columns which are not needed. And for created date, we would require the old created date only when it was lastly created. So we will not drop it, we will just rename it. And here I am changing the data type of that particular column to our timestamp. And for updated date, now that the same record has with the same customer ID has come up in the incremental load as well, so the updated date should be the current date. So this is the implementation which is done over here. This is the implementation for DF new. So if in our incremental load we got a customer ID which is new, which is not there in the already existing gold layer table, then what we are doing is all these tables, DF old, all these tables, all these columns can be dropped because everything will be null. It is not there in the already existing table. For the created date, it will be current timestamp. The updated date also will be current timestamp. So this is the different processing after we have done after separating our new data and old data. After that, for the new data, so new data will not have a customer key. Customer key is the primary key which we are using to uniquely identify our records. So those will not be available for customer key. So for that, what we have done is this is just a mathematical equation which I have written. This is the main implementation. So if the initial load flag is 1, means it is initial load, historical load. So at that time our tables will be empty, we will not have any surrogate key, dim customer key will not be there, it will be empty, so it will start from 0. Else what I have done is fetch whatever is the maximum customer key from the dim customers. So if say we had 200 records, so the maximum customer key, dimensional customer key will be 200. So the next new record which is coming, which is to be inserted in our gold layer, should start from 201. So that maximum dimension customer key we need to fetch, and what we are doing is, as it will come in the form of data frame, so we are collecting only the value from it. And then for the new records, I am just creating the customer key for those records, which will start from the uh, maximum of the dim customer key. So whatever is the maximum, say 200, so it will be 200 plus 1, 200 plus 2, 200 plus 3, like this. And this column dim customer key is coming from here. So this is the dim customer key which I created, which will initially have just 1 2 3 4 5 6, whatever are the number of records. Till there it will have all the monotonically increasing IDs. And then just like say if this is the column and I got 1 2 3 4 5 6 as dim customer keys, so then I will just add this particular one with whatever is the maximum already existing in the table, say 200. So 200 plus 1 will be 201, 202, 203. In this way it will get updated. So that will happen over here. And once we have all our data processing done for our new and update records, then we will simply join these two tables, two data frames. And over here I have implemented the slowly changing dimension type 1. What happens is, to check if a load is incremental or historical, we can do it in two ways. One is by sending a parameter directly, job init load flag. Directly we can check if this flag value is 0, means it is incremental. If it is 1, then means historical. Or else, as I have already implemented in such a way that in the very first load all the tables will be dropped. So I can check if the table exists, then it means it is an incremental load. If the table does not exist, means it is an historical load. So for historical load, whatever is our DF final, which is the union of new and old, we are simply going to write it in EDLS location gold inside the dim customer folder, and it will be saved as a table which is gold dim customers. And say if it is an incremental load, so for incremental loads I need to do SCD type 1, which is using the merge. So I am doing a merge. So I have created a delta object from this path, which is gold dim customers. So from gold dim customers, as it is an incremental load, the table already exists, so whatever is the data over here already there is the old data. So this is the object being created, and this is as our target. And DF final is our incremental data which we have processed and put in our DF final data frame. So that particular part I am merging the already existing path table, basically the data which is already existing in my gold dim customers table, and joining it using the merge with DF final, which is my incremental data with all the processing, which is aliased as source, and this is aliased as target. So I am using dim customer key. So if the dim customer key matches between the new and the already existing one, means it is when matched, then update all, because it is not a new record, it is just an update, or the same record has come in our incremental load, so we can directly update. If the dim customer key does not match with whatever is in the target, then that is a fresh new record, then we directly need to insert it. When not matched, then insert all. So this is the way I have implemented SCD type 1 using the PySpark, and then we can also query in the table what data we got. So this is all the dim customers key 1 2 3 4 5 6. So if it has a certain value, right now here let's imagine it is 6. So in the next load it will check if we have a new data using the customer ID, if it is matching. If it is not matching with the already existing data, then it will create the dim customer key with whatever is the maximum dim customer key plus 1. So this is the way for SCD type 1. So in after SCD type 1, all our data will be for gold customers. It will be in the customers ADLS location inside gold container inside customers folder. Gold and then customers. So we will have all our data over here. Then for gold products, this is the SCD type 2 which I have implemented, and this is being implemented using the declarative pipelines. So this is the declarative pipeline which I have created. So this is the notebook which is for our declarative pipeline, in which I am creating a streaming table, and for that table I have created some expectations such that the product ID should not be null and the product name should not be null. So this is the table name. First I am creating the dim products stage table, and then it should follow all the expectation. It should obey it, such that if it does not obey, any of the record does not obey these particular rules, then it will be dropped. Expect all or drop. And then I have created a stream using the same location, which is our silver's product location, and skip change commits, and this is being read as our stream query. Then I have created a streaming view also on the top of it. So this is live dot, because once our table is created, when our DLT pipeline will be running, so it will automatically pick up from that particular table, and it will create a view on top of it. So this is a streaming view. Then we are creating our final table, which is dim products, which is our streaming table, and using the apply, this is the code format to apply SCD type 2. So in the DLT we can directly use apply changes. What is the target is dim products, what is the source is view. This is the view which we have created, and we are using this as source. It is increment, this is the streaming view, you can directly use it. And then what are the keys to it are product ID, on the basis of which we will check if that particular record already exists or it is a new record. We will check on the basis of this key. Sequence by product ID, we give it because if we have the same product ID, we got more than one records for that product ID in the incremental load, so we can define sequence by, and accordingly it will do SCD type 2, and this is stored as SCD type 2. So this is the code part for SCD type 2. And internally DLT uses a schema catalog, which is database internal, in which all these tables will be there. How it handles everything for the streaming tables inside the DLT pipeline, it will use this particular schema, this particular catalog for DLT purpose. So once this is run, is completed, then we have all our data So once it is completed, we have all our data inside the gold schema. So for DLT, we have it in the in gold schema in the dim products table. So this is not being put inside the ADLS location. If you see over here, we have dim customers and fact orders. These two tables we have, but we do not have for this particular part, which is for products. We do not have in our ADLS location. So that thing is managed internally by Databricks, and it uses the Databricks internal catalog for it. So once everything is completed, we have our data in the gold layers, and this fact orders is the fact table. So for fact table, how I have implemented it is, so if you see, the gold customers is a dimensional table, gold products is a dimensional table. This is SCD type 1, this is SCD type 2. Regions is a static table, hence it does not need the to create as dimension or any other part. Fact orders is a fact table which I have created. So in this, again I am fetching the data from the silver layer, and then fact orders, as it is a fact table, so it will contain all the dim customers keys, all for all the dimensional tables. So basically fact table does not contain anything other than the numerical values and the keys to join with the other dimensional tables. So that part is implemented over here, where I am fetching the dim customer key and customer ID from the dim customers table, and for product again I am fetching all these details, and then I am joining this DF which is our silver layer orders data with the DF dim customers on the basis of customer ID, and DF dim products on the basis of product ID. So basically over here in the fact table, we have joined the gold layer customer table, gold layer products table with the silver layer orders table, these three, to populate fact orders. So it will contain all the numerical values and the keys from all these tables inside it. So this is what it is implemented, and all the unnecessary keys, like the once the joining is done, we can drop the customer ID, product ID, which is not needed. Again I have implemented the SCD type 1 for fact table. If say we get the same record, same entry again, if we rerun the whole pipeline again, then also it should not insert until there is any change to it. So first I have implemented this particular code to handle all the nulls, because if there is a null and we are joining say between the fact orders and the dim customer key, if there is any null, then it will not be able to match and it might get entered in the final table once again. So for the fact new, first I have implemented all the nulls, it should be handled. For dim customer, as it is a numerical value, I am passing it as 0, and for dim product keys we do not have such, so we are directly passing just blank. Dim products key is nothing but the product ID, it's just the rename of that particular column, as we have not created any dimensional surrogate key for that particular dimension, as we are handling it using the DLT code. So this is the null part handling. Then once the null part is handled, then the similar way I am creating a delta object from the gold. So if the table already exists, means it is an incremental load, and if the table is not there, then whatever is the df fact new or data frame, we will just push it as the delta format in this particular location for this particular table. So this table will be loaded for the first time. And if it is an incremental load, so for incremental load we do not need, we have to fetch whatever is the data already existing as of now in the table. So we are creating a delta object for that part, and it is aliased as target, and df fact new is the new data which we got in the current load. So whatever that data is, it is aliased with the source. We are joining the new and the old data using the order id, dim customer key and product key. So once we join it, if the join is happening, we have a perfect join, then it will update the records, means there might be some update that could have happened. And if it is not matched, say dim order id which I have right now in the fact table, it is not there. Like if I got a order id in an incremental records which is not there in the already existing fact orders table, then that means it's a new record and we need to insert it. So this is the way how it is inserting and updating, which is SCD type 1. So the null part, it was handled for this particular scenario only. Say if we joined the fact table, we joined our orders table with the gold layer, silver, gold layer customer table and gold layer product table. So if it joined on the basis of, so say if a particular customer id was there in the orders but was not there in the gold customer table. So let me explain this part. So if we join df, which is our orders silver table, with dim customers. So for this particular scenario, if we consider, if we have a customer id which is in the orders table, and we had the same customer id in our gold layer customers table, so it will be mapped. So we are doing a left join. All the data inside our fact, inside our order silver table should always be there in the df fact, and it is joining on the basis of customer id with dim customers. If it does not match, then it will have value as null for the other columns, which is dim customer id, dim product id, which are coming from these tables. This will have value as nulls. So if it has value as null, then it could happen that this join might not work properly. So if again in the incremental load, like we will have nulls in our final fact order table as well. So if say in the incremental load, again we got some of the records in which the dim customer id something is existing, but it does not have a match with dim customer table, again it will have all these data as nulls, the other record from these particular table. So to handle those parts, nulls are better to be avoided by giving some values, so the joins will work properly and it will not again enter the same record again and again, because nulls cannot be matched. If order id is null and source is also nulls, then it will not be matched and it will keep on inserting the records. So it's better to handle the nulls. So this is the part where I have implemented all the SCD type 1 logic, and then I am finally checking in the fact orders table. So inside it we have dim customer key, dim products key, order ID, everything is there. So this is for fact orders. So this particular pipeline we can pass uh, 1 for the incremental, for the historical load, and 0 for the incremental load, and the same pipeline will work for the both part. Only the difference will be data cleanup is not required if it is incremental load. We will require all the data whatever is there. So hence drop tables and dbs, all these things, this particular notebook will not work for the incremental load. So this is the way I have developed the whole flow. So let me show you by running it as well. So for the very first load I am giving the initial flag as 1, and I will run the pipeline. So if you see, it is an initial flag 1. 1 means historical load. So it is checking. First of all, it is checking if the flag which is provided is 1 or not. So it is true. The flag is 1. So it will drop all the tables, clean all the records. So if we see in our bronze layer, that is empty. Now it is cleaned up. Then we see in our silver layer, it is again empty, it is cleaned up. In our gold layer, empty, it is cleaned up. And all the db tables which were there for our gold, bronze, silver, all those layers will also be deleted. So this is the parameter. This will, what will this activity do is, it will load all the source data from the source folder, from the source to our bronze layer. So as of now I have kept everything in the ADLS part only, so it can be referred. From this particular path we are directly referring to bronze layer. So it will be loading all the data. Checkpoint is basically to capture the incremental load. So whatever is the data loaded, it is captured so that the next time we know what is the incremental data, and if there is no incremental data in the source, then it will not be inserted in this particular location. So it will not have duplicates. It will only insert the incremental record. For that handling, we have a checkpoint location. So this is products, orders, customers, all these are all the data which are put in this particular location from the source. So this is nothing but a raw data. So this is completed. Now our silver layer processing is running. In the silver layer processing, we are doing all the transformations and the data processing by removing all the duplicates, by applying functions, by renaming columns, by creating new columns, by dropping some of the rows. So all the processing will be happening over here, and the data we are going to put in our silver layer ADLS external location, as well as we are creating table, which is a drop and create table on top of it. So all the region, products, orders, customers, everything is created in our silver layer. So now we are doing gold layer data processing. So gold customers is completed. Gold customers. So if we see dim customers, this is already created. And the other part, which is gold products, is a DLT pipeline which is currently running. So this DLT pipeline is not storing the data over here, it is storing and maintaining everything in the Databricks internal schema, which I had showed you over here. Databricks internal, the schema it is using. So this particular table is also loaded. This is our dimension tables. Now fact table has all the fact data, which is our numerical and the surrogate keys. So if we see, this is being put in our ADLS location. So we have fact orders, and we have dim customers also. For products, we have internally managed it using the Databricks. And for silver, just showing you the data. In customers also we have files, in orders also, in products, and in regions. And for bronze, we have just the raw data. So it is our customers, orders, products, and these are the checkpoint locations in which it has schemas, commits, offsets, source. So source is the main folder which captures the idempotency, such that whatever data is processed from the source to branch, the same data will not be processed again, only the incremental data will be loaded. So this helps us to achieve the idempotency. Then we have offsets, then we have commits. This schema, this is basically whatever data we are loading from source to branch, it will infer all the schema inference will be done. So if you want to have schema evolution enforcement modes, so if you want to directly add all the new columns in a rescued data column, you can add it. If you want that the new columns should be added directly into the table, then you can have those schema enforcement modes you can use. And here is the schema which is stored, which will be used for the further incremental loads. So this is for the checkpoint locations. Then just showing you the source files as well. So as of now I have all the files in my location, which is first and second, all incremental as well. Everything is there, and the pipeline is processed. So this is for the historical load, how it works. And for the incremental load, if I just show you that run, so editing the parameter, it is not an initial load, now it is an incremental load. Save. So I am just running this part. So now as it is an initial load, now as it is an incremental load. So for the incremental load, if you see carefully, our drop tables is excluded, because we do not need to drop the tables once again. It is an incremental load. We require all the tables and all the data inside it. So that is implemented, and all the other activities are the same. So this particular part will be excluded, and this particular activity will run if any of the one activity is succeeded. So one part of it is connected with the succession of this part. So if it is succeeded, then also it will execute, or else if this is succeeded with the condition as false, then also it will be executing it. So this is the whole run, and just showing you the data. So these are all the data. So starting from the regions, as we have loaded everything, we have all the data in my regions table. So this is for branch. Then we have our customers table. It is taking some time. So this is all our data in the branch customers table. This is a raw data which we are directly putting from source to branch. Then we have bronze products data, which is the raw data for products. This is our products data. Then we have raw data for orders. So this is the all the data for our orders. This is raw data. Then these are the silver layer tables. So silver layer tables are processed ones, in which we have done some processing using our PySpark code. So this is my silver region table. So region table, just we have dropped one of the column, and then we have the customers table. So customers table, this is our customers table which is transformed. Then we have products. This is our products table. Then we have orders. This is my orders table. Then we have gold layer tables. Gold layer tables, we have customers. So this is using the PySpark code in which we had implemented SC3 type 1. So SC3 type 1, any new changes will be directly updated, and the new records will be inserted. And this is our TIM customer key which we had created, that is sequential. Then we have our products table, product stage table. So this is our product stage table. This all calculations we had done in our silver layer table. Then we have our final products table, which is created using the DLT, which is SCD type 2, to store our history of the data as well. So in this, if you see, there are two columns, which is start at and end at. So these are the two columns which helps us to maintain the history of the record. Say if we got the same product ID in our incremental load, so it will directly update, it will not directly update it over here. It will insert a new row with the same product ID with whatever details which have come up with the incremental load, and the old record, we will have some end date, and then end at we will have some value over here, and for the new record which has come up as an incremental record for the same product ID which is inserted over here, for that part now we will have end at as null, and start at we will be having the same value which we will be having for the end at for the same record with product ID. So this is the way we used to implement the history, like we used to capture and store the history of the records as well. So this is SCD type 2, and then we have our fact table. So this is the fact table in which we have order ID, order date, quantity, total amount, year, dimension customer key, dimension product key, all these we have over here. And then this data I have attached it with Power BI, in which I have all the data loaded, and we can visualize it, all our enriched data using the Power BI. So over here I have created sum of total amounts by brand. I have analyzed it using a pie chart, and the same and I have created one more graph which is for sum of price by category. Similarly, I have analyzing this using the pie chart. So once all our data is there from silver layer, from bronze layer, from our source to bronze layer, then from bronze to silver layer, and from silver to gold layer. So gold layer is the most enriched one, which has the most enriched data. So we are connecting from that tables and we are visualizing it. Just to recap about the architecture, we are using the Databricks using Azure cloud, and we are doing the data processing, which is using the bronze layer. From bronze layer to silver layer, we are using the PySpark to do all of our data processing, and then we connected with the delta live tables for our SCD type 2. SCD type 1 is already being implemented in the silver layer, in the gold layer using the PySpark code, and the SCD type 2 is implemented using the star schema, using the DLT tables in star schema. And finally we are visualizing everything in our reporting, in our Power BI reports. Thank you. This is it from my side.